All right, so we identified the discriminant as something known as b squared minus 4ac, correct? Okay, and we went further, right? We went further to plug those letters into the calculator as variables, and then take that information, find b squared minus 4ac, and then we identified the nature of the roots, right? And we said to identify the nature of the roots, we want to answer the following questions. Question number 1, how many roots are there? Question number 2, are the roots real or imaginary? Question number 3, if they are real, are they rational or irrational, right? And that's how we describe the roots, okay? So what had to happen for each of those 3 scenarios to occur? Well, if the discriminant was negative, what did we know about the roots? Imaginary, very good. If the discriminant is 0, are the roots real or imaginary? They're real. How many roots are there? Only 1. And because there's only 1, it's going to be rational, okay? If the discriminant is positive, right, then we classified it into one of 2 areas. We said that that positive number could be a perfect square, which means rational, or it could be a non-perfect square, which means irrational, right? And that was sort of a review of what we did yesterday. And we looked at all those. We looked at the sketches, so on and so forth. So here I give you some different ways that weird questions can be asked involving the discriminant. Here's one of them, okay? I give you a parabola in variable form, right? So I say it's ax squared plus 4x plus c, plus 2, right? Plus 2. I don't tell you what the value of a is, but I don't want it to cross the x-axis. So I want to find a value for a so that this parabola will not cross the x-axis. Well, for the parabola not to cross the x-axis, what do I know? The discriminant has to be less than 0, because not crossing the x-axis means I have imaginary roots, no real roots, okay? So here's what I'm going to do. Bless you. So here's what I'm going to do. My a value, I don't know, right? So a is what we're trying to find out, right? We're trying to figure that out. The value of b in this problem is 4. The value of c in this problem is 2. But we know that to accomplish our task, the discriminant has to be less than 0. Otherwise, it's going to cross the x-axis, right? So what am I going to do? I'm going to plug in my 2 variables that I know and solve, right? So I have 4 squared minus 4 times a times 2 is less than 0. And so here we get into a case where we got to do a little bit of algebra, right? 4 squared minus 4a times 2 is the same as 16 minus 8a. Agreed? Less than 0. How do I solve that inequality now? Well, I pretend like the inequality is just an equal sign, right? And then I'm just careful that in the event that I multiply or divide by a negative number, I have to what? Flip the inequality, right? So this is a pretty easy one to solve. I can subtract the 16. And we actually run into that scenario where I what? Where I divide by a negative, right? Which means I need to flip my inequality sign, right? So what this is telling me is what? As long as my value of a is a number greater than 2, I won't have any roots. I'll have imaginary roots, won't I? Okay? So that's the kind of question that you could see where you can use the discriminant to accomplish a task. All right, here's another weird scenario, right? I want to have real and equal roots. Now, this is a weird way for me to say something. Guys, if I told you you had two equal roots, you have two equal roots. Give me an example of what the roots might be. 5 and 5. -3 and -3. So if I say you have two equal roots, how many roots do you really have? Only one, right? So I have one real root, which means the discriminant has to equal 0, right? Equal 0. So here I give you x squared minus 4x plus k, and I want to know what value of k will give me the discriminant equal to 0, right? Okay. So my a value is 1. My b value is -4. My c value is k. And I want to make sure that when I set the discriminant, it needs to equal 0 so that I have real and equal roots. So this is where we got to be a little bit careful because my b value is -4, right? So that means I'm doing this, right? What's -4 squared the same as? 16, right? Positive 16 because it's a -4 times a -4, right? All right, so I just substituted, right? (16 minus 4k equals 0). Add the 4k. And the value of k had to have been 4. Cool? All right. Our last problem, right? Our third scenario, actually, right? Is find the, and again, this is where if you don't read and you don't understand vocabulary, you're kind of in trouble, right? It says find the largest integral value of k. What does that mean? When I say integral value, integer, right? In other words, can my answer be any decimal or fraction? No, right? So I want the largest integer that's going to work for this problem. And what do I want to have? I want to have two real roots. Did I specify that the roots need to be real? I'm sorry, rational or irrational? No, they just have to be real, which means positive, right? Positive discriminant. All right, so we got to find the largest integer so that I have two real roots. A is 2, B is 7, C is k. And to have two real roots, my discriminant needs to be greater than 0. Our third scenario. So we have this. And this is another scenario where I just divided by a negative with an inequality, right? So again, flipping the inequality sign. Okay. Has to be a number that is less than 49/8. What's 49 over 8 as a decimal? What do I get? By the way, when you put that in your calculator, right, this is the student who really doesn't know what's going on. They're like, uh-oh, the calculator won't do this. Okay, yeah, I'm sure. How does the calculator give me a decimal? What do I need to do? There's actually two ways to do it, but there's a really, really easy way to do it, Jamie. Control Enter, right? So instead of hitting 49 divided by 8, Enter, if I hit Control Enter, it'll now give me a decimal, right? So 6.125. So what is the answer to the problem? The value of k has to be a number that is less than 6.125. So what's the largest integer that is less than 6.125? 6, right? 6. So k has to equal 6. Everybody good with that? Okay. Again, just weird ways that I can use the discriminant to answer some problems, right? By the way, you see the little hint at the end, right? If these questions show up on an exam, it's not going to give you the hint, right? You obviously have to know which scenario you're dealing with. All right. Guys, guess what? We're not going to even look at this page. With one exception. I need you to highlight, circle, and star these two formulas. Okay? We're going to use those two formulas pretty extensively for the next page and a half of work. What do those two formulas say? The sum of the roots is equal to negative b over a. The product of the roots is equal to c over a. Huh? Sum of the roots, what is it? What is that? What am I doing? What does that mean? I'm going to show you what it means. It's actually very, very simple. Here I give you a quadratic, right? Does that quadratic have roots? Well, if I asked you that question, Jamie, what are the roots of that quadratic? You're going to use your calculator, and you're going to polyroot it. 2, 5, and 8. So Jamie's going to go to her calculator. She's going to assume that they're real unless we figure out otherwise. She's going to go 2, 5, and 8. And she gets the empty set, which means that there's a possibility that the roots are complex or imaginary, right? Guys, remember I showed you this little trick? Instead of going back and retyping everything, if you just go back up, highlight this, and put what in front? A C, yeah. So if I just throw a C in front, it'll now give me the complex roots, right? So there's the complex roots, okay? Do you guys agree that there are two of them? Yeah. Do you guys agree that I could take those two roots and I could add them together? Would I get a really nice answer? No. Could I take those two roots and multiply them? Would I get a really nice answer? Doesn't appear that I would, does it? It doesn't appear that I would. Well, here's what I'm going to do. To find the sum, to find the sum of roots, right? So instead of taking those two really, really complex complex solutions and add them together, it would be sort of a nightmare, right? So I'm going to use this little trick. The sum of the roots is always equal to negative b over a. The product of the roots is always equal to c over a. The stuff underneath what I told you guys to skip on the previous page is the proof of why that works, okay? I'm not going to ask you to do the proof. You're never going to have to do the proof. You're not going to have to even recognize the proof. So, what is my a value in this problem? Everybody? 2. My b value? 5. My c value? 8. So, guys, I want you to get into this habit. What's my negative b value then? Negative 5, right? I have to change the sign. So if I go up to my formula now, the negative b is negative 5. The a is 2. The sum of the roots, in other words, if I took those two roots from the previous problem and added them together, that's what I would have gotten. It's actually kind of a nice answer, right? Not as ugly as we thought it was. Watch this, okay? Watch this. Let me go back to the calculator. Here are my two answers, right? I wonder if I can highlight these. Sure, I can. Okay, so I'm going to highlight these. What's it do? Copies it down, right? I'm going to get rid of this little curly Q. I'm going to get rid of this little curly Q. Ah, wait. Can I do that? Oh, won't let me do that, will it? Ah, that sucks. Oh, I could do this. Okay, you guys probably can't do this, but I can. Copy. Boom. Plus. Copy. Boom. Okay. So what did I do right there, guys? I just took these two things up here, which were my two answers, and I'm going to add them together, right? Isn't that the same as the sum of the roots? And what do we get? Negative 2.5, which is the same as negative 5 over 2, right? So yes, we have our solution, right? So I can use the calculator to check it, right? It's just not real convenient if my answers are kind of ugly like this, right? Now, I know that the next step said to find the product, right? So if I change this plus to be a multiplication sign, oh, here's the problem. I have two things that I am multiplying, right? If I just put a multiplication sign here, is that going to do what I want to do? Or is that only going to multiply these two things? Yeah, so to do this, I actually have to put a set of parentheses there and a set of parentheses there. And now I'm multiplying them, right? And it gives me 4. Okay, well, let's see if this formula, C over A, gives me 4. What's the value of C? What's the value of A? 2. So, yeah, does the calculator do that for us? Sure. But this is one of those scenarios where it's actually a lot easier just to do it by hand, right? It only takes 2 seconds. Cool? All right. So what kind of things can I do? Well, here's one of them. Here I'm going to tell you these are the roots, right? You have 2 roots in a quadratic, 5 plus or minus 2i. By the way, would the quadratic with these roots ever cross the x-axis? No, right? Find the sum of the roots. So I have a root of 5 plus 2i. I have a root of 5 minus 2i. Those are my 2 roots, right? That's what that plus or minus means. You guys agree with that? Because if I add these two things together, what do I get? 10. Right? Because what happens with the positive 2i and the negative 2i? They cancel out. Right? Now I want to find the product of these 2 roots. So that means I want to do this. And you should be like, oh, I'm glad you're doing this, Picardo, because I remember doing this before break. How did we do these before break? If I want to multiply these two things together, what am I going to set up? Tic-tac-toe, absolutely. Or foil, right? Top left box, 5 times 5. 5. 5 times 2i. 5 times negative 2i. Negative 2i times positive 2i. Well, what's negative 2 times 2? Negative 4. And what's I times I? I squared. Now, this is one of those cases where you have to remember that I squared is equal to what? If you don't remember, what can you always do? Yeah, type it in the calculator, but I times I is actually equal to negative 1. Absolutely. So what does that give me? That gives me 25 plus 10i minus 10i minus 4 times negative 1, right? So I just replace the I squared with a negative 1. Negative 4 times negative 1 is positive 4, right? What does that give me? It gives me 25 plus 4, which is 29. Guys, remember something, right? Check this out. 5 plus 2i and 5 minus 2i. What are those called? Somebody said it. Conjugates, right? And what happens when we multiply conjugates of imaginary numbers? The imaginary numbers go bye-bye, right? Again, this is one of those things, guys, that you can really, really easily do on your calculator. What is 5 plus 2i plus 5 minus 2i? Right, there, that was the sum portion. And then if I want to do it as a product, there's your 10, there's your 29, right? So the calculator will do that work for you. Sometimes we got to show it though, right? And so there's both looks. Okay, so why am I doing this, right? Guys, here's what we're actually doing. We're working backwards, right? On that previous page, what did I do? I gave you a quadratic, and I asked you to find the sum and the product. Guess what we're doing right now? We're finding the sum and the product, and we're going to figure out what the quadratic was. So we're working backwards, okay? So how's that going to work? Well, it's going to work really easily, because what did we just figure out? We figured out that the sum of the roots was 10. We all agree with that? We figured out that the product of the roots was 29. Well, Picardo, how is that going to get me to an equation? How's that going to give me the equation of a quadratic? Well, guys, didn't I give you a formula a minute ago to find the sum of the roots? What was that formula? Negative b over a. And didn't I give you a formula to find the product of the roots? And what was that formula? C over a. But 10 and 29 aren't fractions. Yeah, they are. What's my value of a? What's the bottom of both of those fractions? 1. What's my value of negative b? Negative b is 10, which means positive b is negative 10. What's my value for c? 29. So if I know what a, b, and c are, can I write my quadratic? It was 1x squared minus 10x plus 29 equals 0. And this gave me the roots that were described at the beginning of the page. Cool? All right. So we use those tools, and that's sort of the theme of the day, right? We're using these tools to accomplish some different tasks, right? All right, this will be the last thing we do. All right, same exact problem, except now the roots are 3 plus or minus radical 2. Are the roots real or imaginary? Real, right? There's no i's. There's no i's. So my roots are 3 plus radical 2 and 3 minus radical 2. Can you guys find the sum of these two roots? I hope so. 3 plus radical 2 plus 3 minus radical 2 gives me what? 6, because what happened to the radical 2's? They cancel out. Can you guys take these two items and multiply them? Because product means to multiply, right? Find the product of the roots. I got one of those, which means I'm setting up another tic-tac-toe because I got 2 things times 2 things. All right, what do we got here, guys? 3 and 3. 9. Numbers play with numbers. Radicals play with radicals. So what's 3 times radical 2? Radical 2. And this is negative 3 radical 2. Because what number is in front of, what number is in front of this? Negative 1, right? So it's 3 times negative 1, which is negative 3 times radical 2, right? And then I got negative radical 2 times radical 2. What's any radical times itself? The number that was underneath it, right? So radical 2 times radical 2 is equal to, somebody said it, 2. Radical 2 times radical 2 is 2, right? Because radical 2 times radical 2 is the same as radical 4, and radical 4 is 2. Yeah, so this is negative 2. Guys, of course, what could you always do? Take this and type it in the calculator. And if you're not sure, hey, guys, I'm not sure what to put in this box. What can I always do? Right? Or I got 3 hours to sit in an exam, right? And the proctors won't let me leave for 2.5 because that's what the state says, right? So you got plenty of time to do all these things that, you know, I've been showing you over the year, right? You got plenty of time. Okay, what happens with this piece and this piece? They cancel. 9 minus 2 leaves me with 7. So the sum of the roots is 6. The product of the roots is 7. The formula for sum of the roots is negative b over a. The formula for product of the roots is c over a. Uh-oh, they're not fractions. Now they are. So what's A? What's B? Careful with this. Negative 6. It's got to be the opposite of the negative B, right? And then the C is 7. So my equation is that.